we'll do one more exercise, and then I think that should be it for today. And this one should be easy. So I'm going to comment these out. And there's a lot of things you can do with arrays, especially if you're interested in building like a checker game, right, or a chess game. You use two-dimensional arrays. I had a student last year. He actually used not Java, but he used JavaScript, and he built the entire chess game in like 2 weeks or something. Yeah. And one guy, he built it during the weekend using just the two-dimensional arrays. So if you track, what kind of chess, what type is it, the move methods, right? And then you can do, yeah. It gets complicated, but it does deal with just the two-dimensional arrays. It's console. It's console. The other guy, he tried to do the GUI. Actually, he did a GUI using JavaScript, so you can build the tile, and he almost completed it, but it does work. I can see the movement of the chess. So we're going to do something not that complicated, but let's just say that you want to add 2 matrices. And then we'll add that to a third matrix, which is the sum of those, right? So we'll build again, here it doesn't matter what the size. It could be any size. And you can add, because the size can be generated automatically, with random numbers, or you can build it manually and then also get the size from the user. You populate each array with data from the user if you want to, but that's going to take a lot of time, so we're just going to populate some data and we'll do some addition of the matrices. And other things that you can do is like you find a sub-matrix of another matrix, right? So it's pretty fun, right? Fun stuff. And another one, like for a single array, if you think about like an array of numbers, and let's just say if I ask you to sort the array, put all the even numbers in the front, all the odd numbers on the right side, right? How would you do that? You do a lot of swapping, but you have those type of algorithms, or maybe find all the zeros and put them at the end of the list, of the non-zeros in the front. Right? So those are some pretty good exercises, kind of try out. So let's just say we're going to add 2 arrays. This will be just single arrays. Two-dimensional will be, well, actually it is two-dimensional, right? We'll have this is called capital A, and then we'll build some add some numbers in here. So the first one will be like, let's just do very simple ones. 1, 2, 3, 4, 5. The second list. And we'll make this just a square array. It doesn't have to be, but we'll make a square. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. Maybe that's all. That's too many. 3 is enough. So 2 by 3. No, 3 by 5. Sorry. So you can copy this and add another one here. This is our B matrix. And we'll just change this to, I guess, 10s, right? So put a 0 here. 10, 20, 30, 40. And we'll use the 10s. 50, 60. Okay. So we got those two arrays, and then we need to build a third array of, we call it sum. And this is going to be of size So how do you get the size here? So every time I change size A and B, it will always work. So we'll go by A dot length, right? And we'll assume that both A and B have the same size. So then A of 0 dot length. Yeah, yeah, either one would be fine. Okay, so what's the algorithm? How do you add? When I add means like when I add just like the first number add to this the first number here, and then the second number adds to the second number. We'll just do it that way. So and then the third will be just, so we add 1 to 10, and then we put a new number into the new sum array. We'll add 2 to 20, and we'll add that to the second cell in the sum array, right? So like in the sum, we'll have the first, we have like 11, and then 22, 33, 44, and then 55. The second row will be like 22, 33, 44. Is that right? No. It's 21, 32, 43, and then 54 and 65, and so on, right? That's the sum. That way, that's what it should look like. So how do we do this? Right? He knows it. I mean, it's a square, so it's not as hard as a jagged array, right? So, well, we loop through that, right? We do the for loop. We go by row. We do each row at a time. I think we'll see if this works. I haven't attempted yet, but we'll see. So we started with the first row. Again, it's the same size, so we know that we can apply row to both A and B, and even the sum, right? They're all same size. And the row will be less than the A of length, and then the row plus plus. We got the row. Now we'll deal with the column. So same thing like we did before. Column equals 0. Column will be A dot A of 0 or B of 0. Doesn't matter which one. Length, and then column plus plus. And this is what the tricky gets at. Gets into this part here. Well, basically, you're just adding the number 1 through 1 to number 10. So number 1 from the first cell to number 10 in the second array at the first cell, and then you assign a value to the first cell of the sum. Right? So right now, if you look at the first case, row is 0, column is 0. So they're already perfectly lined up. So the row of 0, I want to assign this row 0 in the sum of column 0. So you would say sum of the row and the column, that's 0, 0, this first spot here. I want to store the value, which is the sum of A of 0, 0 and B of 0, 0. Right? Just like that, right? So A of 0, 0, in this case, it will be A of row column. So I get the number, in this case, it will be 1. I'm going to add that to the second matrix, which is B of 0, 0. I mean column here. And that should be it. Right? So the next round will be the next loop. We're still doing the inner loop here. So now the column is now 1. So 1. And then we'll look at the 1. So it'll be 0, 1. So 0, 1. This second spot here, I'm going to assign the value A of 0, 1, which is 2, plus B of 0, 1, which is 20. So you get 22. Assign that spot there. Okay? And it will do all the way to the end of that row, the column, the inner loop. Once we're done, and then we exit out of the loop, we go to the row, the next row, which is now this second row here. We're starting back at 0 again. And then now everything is on the second row. So we move down the row against row wise and so forth. Okay, so now we think we got it. We just have to display it, right? Display the sum. Actually, we should display all of them, but just say we do the sum only. So do that, same thing. Int row from 0 to row less than, you can do A, if you do sum, it's safe if you do sum length, because sum could be different size. Again, for the column from 0 to column less than sum of 0 dot length, again, just to make sure that it works in all cases, right? And when you get better at programming, that's what you have. That's how you think, right? You think at a way that will work in every case. Because if I put in the size of some length or something, a fixed number, then you can have issues. Yeah. Then now we can print the sum of the first row column. Watch, I have to put a print here. So system out print, or just do print, not print line, print the first number plus a space, and then we'll close that print statement. Again, the next line we will print a blank line to see the result. Okay, so we'll see if this works. Well, I have the first two rows here, so hopefully they match. The third and the fourth will look like a similar pattern here. So here we have the first two rows. I got it wrong there. Did I get it wrong? 20, I added wrong, right? Yeah, 22, 33, oh yeah, I added wrong. Math is so bad. This should be like that. It's the same number, you just shifted. So in this case, we're adding, numbers from every cell at the same spot, and we're just assign the new value to a new array. Okay, so this works for a squared array. What if we change, like, again, both the A and B in this case have to be the same size.